Space technologies for the Earth, the future and the trends. Here to talk to you about it, Annalisa Donati, EURISY.
Okay, so good afternoon, everybody. Good Sunday. And just before starting with my presentation, I would like to thank all the organizers for this inspirational event and for having me today to try to provide a little bit of insights on what space can do for society. So let me start and going a little bit through the presentation. So space applications are basically represented by the practical operation of a spacecraft capability and especially of data collected by space systems. There are two general categories of space applications. One provides benefits that are considered public goods and that cannot be easily marketed to individual purchasers, and thus are usually provided by governments using public funds. And examples of these public good space applications could include, for instance, meteorology or navigation. The other category of space application provides goods or services that can be sold to purchasers at a profit. And these applications are the basis for the commercial development of space by the private sector. So let me provide you with a little bit overview on the different applications that I'm talking about today. So satellite navigation, which provides precise location and timing services. And as individuals, we also rely less and less on paper maps to navigate from point A to point B during our daily activities. But finding the way with satellite services in our car or smartphone is just the tip of the iceberg in terms of operational sat-nav applications. So satellite navigation is currently omnipresent in the global transport sector, from digitalization of ports and railways to the guidance of innovative autonomous vehicles. So Europe began in the late 90s of last century to develop its own navigation satellite system called Galileo, which is operated under civilian control. So Galileo became operational in 2016 and now counts 24 orbiting satellites. Other countries and other regions in the world developed their own constellations, such as the Beidou navigation satellite system, which is owned and operated by the People's Republic of China, the GLONASS constellation, which is operated by the Russian Federation, the Indian Regional Navigation Satellite System, and the Quasi-Zenith Satellite System, which is a regional GNSS system, which is owned by the government of Japan and operated by QZS System Services. The second one is satellite communication, which also provide essential services for our daily activities, from telecommunication services, including telephone calls, wireless, mobile, and cellular network providers, as well as broadcasting services, including radio and TV, to data communication, mostly for internet connections. And satellite communication was the first commercial space application, and it has remained the most successful in terms of commercial revenue since then. As of 2020, there are more than 400 commercial geostationary communication satellites around the world, operated by about 60 different owners. The last one is Earth observation, which is the last one in terms of commercial development, and is the gathering of information about Earth's physical, chemical, biological system via remote sensing technologies. EO is used to monitor the status of and the changes in the natural environment and human landscape. So satellite imagery allows for an integrated view of land uses and infrastructure, for instance. Copernicus is the European Union's Earth observation satellite program, looking at our planet and its environment for the ultimate benefit of all European citizens. The Copernicus information services provided are freely and openly accessible to all, and Copernicus has become the world's leading provider of Earth observation data and information. So as we can see, space-based technologies nowadays deliver reliable and repeat coverage datasets, which combined with other data, provide a unique means for gathering information concerning our planet. So basically, if we are still wondering why we are speaking about satellite application, this is especially because we are meeting at a time of immense challenges to sustainable development. So natural resource depletion and adverse impact of environment degradation, including desertification, drought, land degradation, freshwater scarcity, and loss of biodiversity exacerbate the list of challenges which humanity faces right now. Climate change is one of the greatest challenges of our time, and its adverse impact undermine the ability of all countries to achieve sustainable development. So to address those challenges, it's necessary to develop new and integral approaches. And satellite data are by definition, in this sense, objectives, scalable, and shareable. However, satellites are often still considered mostly as technology demonstrators rather than components of a critical communication and information-based infrastructure, providing core data to optimize decision-making processes in modern society. And here comes at play EURISY, and I would like in this moment to give the floor to my predecessor, Mr. Jean-Jacques Tortora, former EURISY Secretary General, and to our President, Ms. Dominique Tillmans, to explain a little bit what EURISY does and how we are basically bridging the gap between space and society. So please broadcast the video. Thank you very much.
Years ago, with a mission to bridge the gap between space and society. And frankly speaking, 30 years ago, this was quite visionary because at that time, certainly we could hardly anticipate all the challenges that would arise from the broader use of space-based solutions in our everyday life. And I'm very happy and proud today in my capacity of Secretary General of EURISY to salute the vision that our funders had at that time.
A few years ago, space was inaccessible to most of the people, but space evolved and contributes to the general economy. Agriculture, the blue economy, the digital economy, in mobility and environmental management, space application in healthcare, telemedicine and pollution monitoring. And who could have thought that space application could serve culture? Space is entering in a new area never imagined.
GNSS-based space imagery options as a supporting tool to draft social and economic policies are irreplaceable. EURISY has been working along these lines for 30 years now, and I'm quite convinced that it has kept all of its relevance today, putting space-based capacities to work in the best possible manner for the benefits of citizens in Europe and around the rest of the world.
EURISY is an association whose members comprise mainly space agencies around Europe, as well as some research institutes, offices and departments. Our purpose is to promote the benefits of satellite application in sectors that may have nothing to do with space. We have embarked on a program how satellite application can benefit all of us. Our motto encapsulates what we do: acting collectively to bridge space and society. We push the doors. We are only beginning. And we are pioneers.
Hear the sound as well, because from here it was not really possible, but now, I mean, after this overview of what we do, I would like to bring you a little bit more into the practical example. Yes, thank you. So exactly, I would like to bring you a little bit indeed more into the practical examples of what satellite applications are currently doing in different economic and professional sectors. So the first case I would like to introduce address agricultural productivity. And as agriculture moved basically to mass production, farmers regularly increased the quantity of fertilizers and water to rise crop yields. These practices led to sometimes disastrous results, from water loss to soil degradation to ecosystem damage and human water supplies contamination. And the agricultural cooperative of Nestos, which is located in the northern Greece, offered basically part of its land to AgroLes. AgroLes is a project using satellite imagery plus in situ and meteorological data to produce real-time soil maps. And since the introduction of this application, the cooperative members reduced their water consumption by up to 60%. And the distribution of fertilizer and pesticides had also been improved at a pace of 3%. The next case, it's about biodiversity and the management of forests. And it's about the Swedish forests. Because as we know, Swedish territory, it's covered by forest for about the 70% of its whole territory. And about 90,000 people are currently employed in the forestry sector, which generates an export of about 12 billion euros. So the Swedish Forest Agency, SFA, is the public body in charge of ensuring the implementation of the Swedish Forestry Act, which aims to maintain production levels while at the same time protecting biodiversity. So under the Forestry Act, private forest owners are obliged to replant the forest's land, which has been cleared in the previous years, and to notify this work to the SFA. So according to the SFA, after the introduction of the imagery, basically there was a sizable fall in the forest areas cleared illegally, and there was a huge help for them in the control of this clearance of the territory. The next case is about water management, which is of course a resource that is very important for all of us. And here I'm talking about ENAS, which is the Ente Acque della Sardegna, in charge of developing, operating and maintaining the water infrastructure in the Italian region of Sardinia. So the Sardinia raw water reserve is stored in 32 large dams spread all over the territory, from which it is transported to the supply of the industrial, agricultural and all the civil sectors. So from its decentralized headquarters, ENAS manages installations spread over a large area of about 25 square kilometers, which is characterized by a very varied orography and a low population density. So in addition to the time and the workforce needed to visit all the water installations, the region's terrestrial telecommunication infrastructure is quite unavailable or totally unreliable outside of the urban or industrial areas. So ENAS decided to deploy a satellite communication network to monitor the water quality of the Sardinian reservoirs and to extend it also to all the different water infrastructure in the region. So the choice of using a scalable, simple and easy manageable system has provided very successful, allowing ENAS to have an overview of the whole water distribution system, irrespective of the distance of the employees, which are scattered on the whole territory. So eventually the last case I would like to illustrate is a case about Finland, and illustrates how the Finnish transport agency, responsible for keeping Finns on the move all year round by developing and maintaining the country's roads, railway and waterways, is currently coordinating traffic routes on the 55 Finnish ports. So Finland is, first of all, the only country in the world where all the ports freeze in winter. And in 2014, the 77.5% of Finnish imports and the 89.6% of exports passed by sea. So keeping ports open and navigation fluid during winter months is therefore of vital importance for the country's highly industrialized economy. So since 1991, Finland has fully replaced data collected from helicopters with satellite data. And unlike helicopters, radar satellite imagery, for instance, offer a wide area coverage day and night and in all weather conditions. So currently, satellite data is combined with in-situ observation to produce information available to each icebreaker captain directly and ready for use to a shared information system, which is called IBNet. So the switch has resulted in a number of concrete benefits for the agency, which calculates saving of about 1 million euros just by reducing the fleet's fuel consumption. And giving up the use of helicopters, the agency saved a further 8.2 million over the last 11 years. So this is quite of a sensitive number. here, I would like just to briefly introduce this brochure, which is basically introducing the Space for Cities initiative, which aims at exploring current and potential use of satellite application to make our cities healthier, cleaner, safer, and more efficient, with the ultimate objective to promote user-friendly satellite-based services and products. It is indeed fundamental nowadays that cities are prepared to profit from these resources, that their needs are carefully addressed and considered when developing new products and services. So this brochure provides just an overview of the potential aspects that satellite could address to support better decision-making processes in all our cities. But cities, agriculture, water management, maritime are not the only economic sectors that are attached that can benefit from satellite-based application. We also have sectors like tourism, sport, art, and culture that today I could not mention, but that really deserves to understand what satellites can do. And in this sense, I invite all of you to visit our website, which has one of the largest European database on success stories on the use of satellite-based application from early adopters. Before concluding my presentation, I also would like to basically tell you a little bit on the figures of the value of the space economy. So in its later research, Euroconsult, for instance, estimates that the consolidated space economy, including both government space investment as well as commercial space, total $385 billion in 2020, which is a record amount. And in this amount, commercial downstream revenues are the biggest share, which is driven still by the direct-to-home television, which is estimated of about $91 billion in 2020, and which is closely followed now by PNT service. So according to recent studies conducted by the EU, the main downstream market for GNSS application are handheld location-based services and in-vehicle satellite navigation system. And in the next 2 decades, the Galileo is expected to generate economic and social benefit worth of about 60 to 90 billion euros. The same is for Earth observation, in the sense that the demand for Earth observation value-added services that currently mainly originates from the public sector, it's going to be increased by various commercial market with a lot of unexplored potential. Relevant market segments relate to natural resource management, defense and security, land monitoring, as well as oceanography or meteorology. And it has been estimated that by 2030, the annual turnover of EO downstream services will be of around 3 billion euros, of which the 90% will stem from Copernicus-enabled downstream markets applications. However, also it needs to be highlighted that although a lot has been done, the actual uptake of European downstream space market has been below expectation. Several barriers might be mentioned that have constrained the development of the sector. Among these, we have for sure like political barriers. Indeed, too often the data are not even, satellite data are not even explicitly mentioned as source of policy development. Market constraint about the access to market and the access to space itself, the governance issues coming more often from a fragmented governance, technical issues and unsuitable dissemination as well, and to a less extent, a lack of skills. But how I want to conclude? I want to conclude by the opportunity and the trends that we see right now in the space downstream sector. So first of all, the institutional actors are taking again the leading role in the definition, update and also implementation of space policies to foster economic growth and to face the challenges such as sustainability and indeed the green development. So the green transition, and among which I'm talking about the European Green Deal initiative, is expected to stimulate the demand for advanced satellite-based application. In addition, what we do see is a democratization of space, and by this I mean the increased number of actors and the diversification of the actors that are currently entering in the market. So a market which is not anymore dominated by the government, but there is actually, really like in parallel is seeing an increased number of private actors that are leading the role. Another great opportunity is provided by the digital technologies. So the digital technologies such as cloud technologies, artificial intelligence, rather than IoT or additive manufacturing or blockchain, have an high competitive advantage in the sector, because by merging those technologies, by powering those technologies with satellite data, there's an endless number of opportunity in terms of business that can be produced. Eventually, also, there is a change that we are seeing in the way in which we communicate about the benefit of satellite application. We realize that put on the spotlight early adopters of satellite application to talk about their benefit is the right way to go, and is the right way to really widespread the awareness on the benefit of a satellite application for society. So this is actually the end of my presentation. I hope I've been insightful and I provided you with an informative presentation, and I'm open for any question if you wish. Thank you very much for the attention.